There are diesel engines that were powerful. There are diesel engines that were efficient. And then there was the Detroit Diesel 6-71. It didn't look like a masterpiece. It wasn't the biggest engine on the highway. It wasn't the most advanced. It didn't have modern electronic controls, common rail injection, variable geometry turbochargers, or computers making thousands of decisions every second. What it had was something much harder to engineer: simplicity. And somehow, that simplicity helped make the 6-71 one of the most recognizable two-stroke diesel engines ever built. For decades, this engine lived in trucks, buses, boats, construction equipment, generators, military machines, and industrial equipment. It worked in places where failure wasn't just expensive. Sometimes failure meant being stranded hundreds of miles from civilization. But here's the mystery. How did an engine designed around an old two-stroke concept survive for so long when four-stroke diesels were becoming more sophisticated every year? Why did mechanics love an engine that could be loud, smoky, and demanding? And why do people who worked around these engines still talk about the 6-71 with a kind of respect usually reserved for machines much more complicated? The answer begins with an idea that sounds almost backward today. Instead of trying to make the engine smarter, Detroit Diesel tried to make it brutally effective. The story of the 6-71 begins with General Motors' Detroit Diesel division and the development of its famous Series 71 family. The number, 71, wasn't a horsepower rating. It referred to the approximate displacement of each cylinder. The six-cylinder 6-71 displaced roughly 426 cubic inches, or about 7.0 liters. 7 liters doesn't sound enormous by modern heavy-duty standards. That's exactly what makes the engine interesting. Because the 6-71 wasn't trying to win by being huge. It was trying to win by extracting useful power from a compact package. And the secret was sitting inside the engine itself. The 6-71 was a two-stroke diesel. That single fact changed almost everything. A typical four-stroke diesel needs 4 piston strokes to complete its cycle. Intake, compression, power, exhaust. The 6-71 worked differently. Every time the piston moved through a complete two-stroke cycle, the engine could produce a power event. That meant every cylinder had a combustion event every revolution instead of every other revolution. On paper, that sounds almost unfair. But there was a problem. How do you get fresh air into the cylinder and exhaust gases out when the engine doesn't have a dedicated intake stroke? Detroit Diesel's answer was one of the defining features of the engine: a blower. The 6-71 used a mechanically driven Roots-type blower to force air into the cylinders. This wasn't just a turbocharger added for extra performance. The blower was essential. It helped clear the burn exhaust gases from the cylinder and pack the cylinder with fresh air for the next combustion cycle. Near the bottom of the cylinder wall were intake ports. As the piston moved downward, those ports opened. Pressurized air from the blower rushed into the cylinder. At the same time, exhaust gases were leaving through valves in the cylinder head. This process was called uniflow scavenging. It was a beautiful piece of engineering. Fresh air came in from the lower part of the cylinder. Exhaust gases went out through the top. The flow had a clear direction. And that simple arrangement allowed a two-stroke diesel to breathe rapidly enough to operate at serious engine speeds. But there was another reason the 6-71 became legendary. Its architecture was incredibly modular. Detroit Diesel designed the Series 71 family around common components and shared engineering principles. That meant the same basic concepts could be scaled into different configurations. 3 cylinders, 4 cylinders, 6 cylinders, 8 cylinders, and eventually massive V configurations. For mechanics, that mattered. An engine wasn't some mysterious machine designed from thousands of completely unique parts. There was a family resemblance. You could learn one Series 71 engine and understand much of another. That was powerful. Because trucking wasn't just about horsepower. It was about keeping the machine moving. Imagine a truck sitting beside a highway in the middle of nowhere. The driver isn't thinking about engineering elegance. He's thinking about getting home. A fleet owner isn't thinking about combustion theory. He's thinking about downtime. A mechanic isn't thinking about marketing. He's thinking about whether he can diagnose the problem and get the engine running again. And this is where the 6-71 built its reputation. The engine was mechanically controlled. Fuel delivery was handled through individual unit injectors, with the engine's camshaft operating the injection system. There was no electronic engine computer deciding exactly how much fuel to inject. No laptop required to tell you what the engine was thinking. The mechanical system had to do the job. And that meant the mechanic had a direct relationship with the machine. You could listen to it. You could feel it. You could inspect it. You could adjust it. That doesn't mean the engine was primitive. Far from it. The unit injector system was actually a clever way of combining fuel pumping and injection into one compact assembly. Each cylinder had its own injector. The camshaft controlled the timing and operation. Fuel was delivered under extremely high pressure directly into the combustion chamber. That gave Detroit a way to control injection accurately without needing a separate high-pressure fuel pump and complicated distribution system. And the engine's sound became part of its identity. The 6-71 didn't whisper. It screamed. That sharp, mechanical two-stroke sound became unmistakable. The blower whined. The exhaust barked. The engine climbed through the rev range with a character that modern diesel engines rarely reproduce. People who grew up around these engines could often recognize one without seeing it. But the sound was only part of the story. The 6-71's real strength was its power-to-weight ratio. Depending on configuration, rating, application, and era, 6-cylinder 6-71 engines were commonly found in horsepower ranges around the low hundreds and beyond, with some later and turbocharged versions producing significantly more. Exact ratings varied widely. And that matters. Because the 6-71 wasn't one single specification. It was a platform. Detroit could tune the engine for different applications. A bus engine didn't necessarily need the same characteristics as a truck engine. A generator had different requirements. A marine application had different demands again. The same fundamental architecture could be adapted to the job. That flexibility helped spread the 6-71 everywhere. And once it became established, another advantage appeared. Parts availability. When an engine is produced in huge numbers for decades, an entire ecosystem forms around it. Mechanics learn it. Machine shops learn it. Parts suppliers stock components. Fleet operators know where to find someone who understands it. The engine becomes more than a machine. It becomes an industry. And that is how a 7-liter 2-stroke diesel ended up with a reputation far bigger than its physical size. But the 6-71 was not perfect. That is important. Because legends become boring when people pretend they had no weaknesses. The 6-71 had them. The 2-stroke design demanded a constant supply of clean air. The blower was essential. The engine could be sensitive to poor maintenance. Oil control mattered. Cooling mattered. Fuel system condition mattered. And the engine had to be operated properly. Then there was the issue of noise. A 6-71 could be brutally loud. To some drivers, that was music. To others, it was a headache. The engine also had a reputation for producing visible smoke under certain conditions. And because the engine relied on a mechanically driven blower, it carried a parasitic load. The blower had to turn all the time. That consumed some of the engine's power. But Detroit understood the trade-off. The blower wasn't there because engineers couldn't build a turbocharger. It was there because the engine needed positive airflow for scavenging. And that distinction is critical. The blower was part of the engine's breathing system. Later versions could combine the blower with turbocharging. Now the engine had a fascinating relationship between two different forms of forced induction. The turbocharger could provide additional air and power. The blower ensured the engine still had the airflow characteristics needed for scavenging and low-speed operation. It was mechanical engineering solving a problem that modern engines often solve with electronics. But there was another challenge. A two-stroke diesel fires every cylinder once per crankshaft revolution. That creates tremendous opportunity for power. It also creates tremendous heat. The combustion system has to work constantly. The cooling system has to keep up. The lubrication system has to protect components under serious operating conditions. And the engine has to survive the stresses of repeated combustion events. That is why the 6-71's internal architecture was so important. The engine block was designed for durability. The cylinder liners could be serviced. Major components were accessible. The design was built around repair, not replacement. That difference tells you something about the era when the engine was created. Today, if a complex electronic component fails, the repair process can involve diagnostics, software, sensors, wiring, control modules, and specialized equipment. With the 6-71, the diagnosis could start with your ears. Is it missing? Is the blower making the wrong sound? Is the exhaust smoke changing? Is the engine running hot? Is the oil pressure behaving normally? The machine communicated. The mechanic had to listen. And the best mechanics became almost fluent in that language. But the story gets even more interesting when you look at where the 6-71 worked. It wasn't just a truck engine. It became a workhorse across transportation and industry. Buses carried it. Construction machines relied on it. Generators used it. Boats pushed through water with it. Military equipment depended on the Series 71 family. And countless vocational machines operated far away from the spotlight. That's the kind of success that doesn't always make headlines. Nobody makes a documentary about the generator that started every morning for 20 years. Nobody celebrates the truck that quietly delivered its load and returned home without breaking down. But that's exactly how industrial legends are created. One ordinary day at a time. One successful start. One heavy load. One long highway. One repair that actually worked. And then another. And another. By the time the 6-71 became an established name, generations of drivers and mechanics had developed opinions about it. Some loved it. Some hated it. But almost nobody ignored it. And that's when the engine's biggest contradiction became obvious. The 6-71 was old technology. Yet old technology doesn't automatically mean bad technology. Sometimes it means the design had enough time to mature. Think about what Detroit was really doing. They were balancing displacement, engine speed, airflow, fuel delivery, cooling, weight, packaging, maintenance, and manufacturing. And they had to do it without the computing power engineers take for granted today. There were no digital simulations running thousands of virtual tests overnight. No modern engine control unit constantly correcting fuel delivery. No sophisticated network of sensors monitoring every parameter. The engineers had to understand the machine physically. They had to know how air moved, how fuel burned, how metal expanded, how bearings survived, how pistons behaved, how oil moved through the engine, and how the entire system would react when a driver put the throttle on the floor and kept it there. That is what makes the 6-71 so fascinating. It wasn't just a collection of parts. It was a mechanical system designed around a clear philosophy. Make it understandable. Make it serviceable. Make it durable. And make every component earn its place. But the world around the 6-71 was changing. And this is where the story takes a darker turn. The same qualities that made the engine famous eventually became limitations. The trucking industry wanted more power, more torque, better fuel economy, lower emissions, quieter operation, and eventually electronic control. Modern emissions regulations would make the old two-stroke design increasingly difficult to justify. The engine could be developed and modified, but there were limits. Every improvement came with trade-offs. More power created more heat. More airflow demanded more engineering. Lower emissions required better combustion control. Fuel efficiency became increasingly important. And four-stroke diesel engines were advancing rapidly. The future was arriving. It was quieter, cleaner, more electronically controlled. and increasingly sophisticated. The 6 to 71 belonged to another philosophy. It was built in an age when the driver and mechanic were part of the engine's operating system. The driver had to understand the machine. The mechanic had to understand the machine. The fleet had to maintain the machine. The engine didn't hide its problems behind a warning light. It told you. Sometimes loudly. Sometimes violently. Sometimes with a cloud of smoke that made the diagnosis impossible to ignore. But here's the part people often misunderstand. The 6 to 71 didn't disappear because it suddenly became a terrible engine. It disappeared because the world changed around it. That's different. An engineering design can be successful for decades and still eventually become obsolete. The telephone didn't stop being useful because smartphones appeared. The old engine didn't suddenly forget how to work because electronic diesels arrived. The requirements changed. The standards changed. The economics changed. The technology changed. And eventually, the 6-71's era began to close. But the engine refused to vanish completely. That is perhaps the most remarkable part of its story. Even after newer engines took over the mainstream market, Series 71 engines continued working in countless applications. Some were rebuilt. Some were modified. Some were converted. Some simply kept doing the job they had always done. And decades later, you can still find examples of these engines running. That tells you something. A disposable product is designed to be replaced. A great machine is designed to be repaired. The 6 to 71 was very much from the second category. And its serviceability became one of its greatest survival mechanisms. A worn component didn't necessarily mean the end. A tired engine could be rebuilt. A damaged component could be replaced. A mechanic with experience could bring an old engine back to life. That is why old diesel engines have an unusual relationship with time. They don't always die. Sometimes they simply change owners. One truck retires. The engine moves to another application. A machine gets scrapped. The engine gets rebuilt. A fleet sells equipment. Someone else buys it because they know exactly what is sitting between those frame rails. The 6 to 71 became part of that cycle. And then there is the sound. You can't explain the legacy of this engine entirely with specifications. You have to hear one. The rapid firing rhythm. The blower whine. The mechanical clatter. The sharp exhaust note. The way the engine seems to build intensity as the RPM climbs. It feels alive. Almost angry. And that emotional reaction is part of why people still remember it. Modern engines can produce astonishing power. They can be cleaner, quieter, more efficient, and far more precise. But precision doesn't always create personality. The 6 to 71 had personality in abundance. It had quirks. It had demands. It had limitations. But it also had an unmistakable identity. And perhaps that is why the word masterpiece still gets attached to it. Not because it was flawless. It wasn't. Not because it was the most powerful diesel ever built. It wasn't. And certainly not because it was the most technologically advanced. It wasn't. The masterpiece was the balance. A relatively compact displacement. A two-stroke operating cycle. Mechanical fuel injection. A roots blower. Uniflow scavenging. Serviceable architecture. Modular components. And a design philosophy that prioritized real-world work. All of those decisions had consequences. Some were advantages. Some were compromises. But together they produced an engine that could survive decades of hard use. That's engineering. Not chasing the most impressive number. Solving the problem. And solving it in a way that makes sense for the people who actually have to use the machine. The 6 to 71 also teaches us something about technological progress. Newer doesn't always mean more memorable. Modern engines are marvels. But their complexity can make them feel distant. The 6 to 71 was different. You could stand beside it and understand what you were hearing. You could see the mechanical parts doing their work. You could feel the vibration through the machine. And when the engine fired, there was no question about whether it was alive. It announced itself. That is why mechanics still talk about these engines. That's why old truckers remember them. That's why restorers keep them running. And that's why a 7-liter 2-stroke diesel can still generate conversations decades after its prime. Because the 6-71 wasn't simply an engine. It represented an entire era of American machinery. An era when equipment was expected to work hard. An era when mechanical knowledge mattered. An era when a skilled mechanic could take apart a complicated machine, understand what had failed, replace what was worn, adjust what needed adjustment, and send it back into the world. The 6-71 embodied that philosophy. And perhaps the greatest irony is this. The engine's biggest weakness eventually helped define its legacy. It was built around a technology that couldn't keep pace forever. The world demanded cleaner emissions, better efficiency, more refined control. The 2-stroke diesel's advantages became harder to justify. The future belonged to 4-stroke engines and electronic management. So the 6-71 eventually became a relic. But relics don't usually keep working. This one did. And that's why the story isn't really about an old diesel engine. It's about an engineering idea that survived long enough to prove itself. The Detroit Diesel 6-71 was never perfect. It was loud. It could be smoky. It could be demanding. It needed maintenance. It had compromises. But every great machine has compromises. The real question is whether those compromises were worth what you got in return. And with the 6-71, the answer was proven millions of times over. It hauled. It powered. It pushed. It pulled. It carried people. It ran equipment. It worked through heat, cold, dust, long hours, and hard service. And when the era that created it finally disappeared, the engine didn't disappear with it. Some are still running. Some are still being rebuilt. Some are still sitting in old equipment, waiting for someone who understands what they are looking at. That is the final reason the 6-71 deserves to be remembered. Not because it was the biggest. Not because it was the fastest. Not because it was the cleanest. But because it solved a difficult engineering problem with remarkable clarity. Give a machine enough air. Give it the right amount of fuel. Control the combustion. Keep it cool. Keep it lubricated. Make the major components serviceable. And build it well enough that a mechanic can bring it back when time starts winning. Simple ideas. Brilliant execution. That's the difference. And maybe that's why, decades later, when an old Detroit Diesel 6-71 fires up, people don't just hear an engine. They hear an era. An era when machines had voices. When mechanics diagnosed problems with their ears. When truck drivers knew their engines by feel. And when engineering wasn't always about adding another computer, another sensor, or another layer of complexity. Sometimes, it was about finding the simplest answer to a brutally difficult problem. The 6-71 found one. And for generations, it proved that answer on the road. So the next time you hear that unmistakable 2-stroke Detroit scream, remember what you're actually listening to. Not just an old diesel. Not just a piece of trucking history. But one of the clearest examples of mechanical engineering from an era when simplicity, serviceability, and durability could turn a 7-liter engine into a legend. The Detroit Diesel 6-71 didn't become a masterpiece because it was perfect. It became a masterpiece because it worked. And sometimes, that is the highest compliment an engine can ever earn. If you enjoyed this deep dive into one of America's most unforgettable diesel engines, subscribe for more stories about the machines that built the roads, powered the industries, and changed trucking forever.